measures of position. We're talking about numbers that mark like, okay, where in the data set are we? Are we like 25% through? Are we in the middle? Is it like a really big number and it's like 75% through? Stuff like that. And well, we have a couple numbers to describe measures of position. The first one is the z-score, which we will be quizzed on today, right? So z-scores is our quiz. After we talked about z-scores, I talked about quartiles, where if I numbered the numbers from like lowest to greatest, well, sometimes we're interested in the median, which cuts the data in half, but sometimes I want to get even more precise than that and cut the data into quarters, which is why we have our quartiles, like our first, our second, and our third quartiles, which we talked about before. Now, we do have ways to compute quartiles. The first thing you have to do is to order your data from smallest to largest, just like you were finding the median, right? If you're looking for the first quartile, you're going to take 0.25 because it represents the first quarter of the data. You're going to multiply that by the number of data items that you have, so the last number that you have there. You're going to get a number when you multiply those together. If you get a decimal, you're going to ignore every single law of math that you've ever learned, and you're going to round the number up to the nearest whole number. So even though you might get 5.25, you're still going to round that up to 6. Whatever number you get, like 2 or 6, is the number that you're going to look in your data set. So if I get 2, my second number, or 82, is my first quartile. If I get 6, my sixth number, or 98, is my third quartile. Okay. Now, we didn't do as much practice as I'd like on Wednesday, so we will do a lot more practice with these today and also Monday. So you're going to get sick of actually computing these and so on. Now, let's just say you multiplied together and you got a whole number. Well, then we don't do the rounding up thing because, well, we have a whole number. What you're going to do is you're going to find the number in that position that you calculated. For example, position 2. You're going to find the number in position 3, and you're going to take the average of the two to get your quartiles. Very similar to finding the median. Okay. All right. After we talked about quartiles, well, in quartiles, we're talking about, okay, like, where are the quarters of the data? Like 25%, 75%. But sometimes we're not just interested in the quarters. Sometimes I want to figure out, okay, like, what's, I don't know, 52%, or what's, I don't know, 85% of the data. And that's why we have these things called percentiles, which are basically quartiles, but we can do any decimal instead of just 25 and 75. For example, if you took the SAT and you got the 19th percentile, that would be a very bad score because it meant that you only did better than the 19% of everyone else who took the exam. So it's good to have like a high percentile if you want a high number on your test. Okay, so we did a couple examples. So first of all, I had example number 5. I had these numbers. The first thing I did was I wrote the numbers in order. I also numbered each of the numbers. So I know like what the 7th number and what the 3rd number is and so on. Okay. To find the 14th percentile, I just took 0.14. I multiplied it by the number of things. I got a decimal. Even though it was 1.12, I still rounded it up to 2 because we're ignoring the laws of math here. For percentiles, we just round up. And our second number was 25. Okay, let's do the 50th percentile. Now, I could go ahead and do the percentile way just like we normally do, but what's another name for the 50th percentile? The second quartile, good, which is the median, good. So I'm actually going to write all of those out. So second quartile, the median Q2. We actually have like what, 4 names for the median now. I personally just like finding the median. You can go ahead and do the same process as we did before, but I'm just going to cross out pairs. So we got 20, this guy, I'm going to cross out these guys, and it looks like I'm left with 34 and 39 in the middle. And well, let's find the average of these two. 34 plus 39 divided by 2. I'm going to do that in my calculator because I forgot to do this in my notes. I'm getting 36.5. Does everyone agree with me on that? Sounds about right. Okay. So when you're asked for the 50th percentile, just find the median. You really don't have to. No, you should probably get the same answer. Yeah. I'm doubting myself, but yes, you should get the same answer. Oh, so you would do 0.5 times 8, right? And that would be 4. So you'd find the number in the 4th position, which is 34. You'd find the number in the 5th percentile, the 5th position, which is 39. And then you take the average of the two, and it's the same thing. Yeah. Yeah. So either way is fine. I just like crossing off because it, I don't know, looks nicer. All right. Good question there. Any other questions? All right, let's do the 40th percentile together, just so we're on the same page here. If I want to find the 40th percentile, what is the decimal that I'm going to use? 0.40 or 0.4. What am I going to multiply that by? 8, because that's the number of things that I have. So let's go ahead and do that. 0.4 times 8, I'm getting 3.2. All right. What does 3.2 round up to? 4, good. And is 4 my 40th percentile? No, what is it? 4th number, which is 34. Good. So 4th number is 34. That is the 40th percentile. All right. I'm going to give you like 1 minute to find the 25th percentile, and then we'll come back. I would normally walk around, but I am, my feet are off duty today. So I'm going to sit here.
Your 8 a.m. Jeremy, your 8 a.m.
Yeah.
Jeremy, Jeremy and I were talking about you yesterday because we both have you as a teacher.
Oh yeah, I know Jeremy. He's in my first class.
Yeah, Jeremy's one of my friends.
Oh, wow. His class it's the 8 a.m. class, and everyone's like half asleep during it.
Yeah. That's his only class on Fridays.
Oh, that's sad. At 8 a.m. That's just really unfortunate there. At least it's over with. All right, let's go through the last one. The 25th percentile. Can someone give me another name for the 25th percentile? First quartile, or Q1, right? So really we're just doing the quartile here, even though it's a percentile. What did we multiply together? Perfect. And when we did that, what did we get? 2. Now, do I do the rounding up thing here? No, right? We have to find the second number, right? So number in position 2, which is 25, right? What other position am I looking at? Position 3. So I got to find the number in position 3. Which number is that? 32. And I just have to find the average of these two. So I add them together, divide by 2. What is the 25th percentile? 28.5. Perfect. All right. Any questions on part D? Sounds good. All right. Let's flip over the page. This okay, I'm using the wrong set of notes. I used the set of notes like my first couple semesters teaching. I used to teach a lot more in this class because I didn't really realize what was on the syllabus and what was not on the syllabus. This is an example of something that is not on the syllabus. It's not on the final. So I'm just going to put a big X through this and the next example because, well, we're not really required to learn it. I'm sure you would be fine learning it, but if we don't have to learn it, then are we really going to do it? I don't think so. Okay. Next thing that we're going to learn about is the 5-number summary. So the 5-number summary is literally a list of like the 5 most important numbers when we're talking about position in a set of data. So when we come up with our 5-number summary, we're going to find the minimum number. Okay, so the lowest number. We're going to find the first quartile, the second quartile or the median, the third quartile, and then the maximum number. And those are like the 5 biggest numbers in our set of data. And that's what we're going to put in our 5-number summary. So what we're going to do here is we are actually going to recall all the way back to example number 2. I know that's a long way back because I rearranged the set of notes and I did not mean for us to go back that far. But if you go back to example 2, we have the set of data and we found the first quartile, the median or second quartile, and the third quartile, 82, 96, and 98. So let's just recall here, when we did this, I found that Q1 was 82, the median was 90, was it 96? There we go, 96, and Q3 was 98. Okay. So that's just from example number 2. We already did that. Let's just pretend that we did that in class right now. Okay. let's say if I wanted to find the 5-number summary, the first thing I need to do is find the lowest number. What is the lowest number in the set of data? 77, right? So that goes first. Okay, so it's the lowest. What should go next? 82, right? Because that's my first quartile. What goes next in my 5-number summary? 96, perfect, because that's my median. What goes fourth? 98, because that's Q3. And what is my highest number in the set of data? 100, perfect. So this is my 5-number summary. It's literally just a list of 5 numbers, usually separated by commas. They should be increasing in order. You shouldn't ever have like it go up and then down. It should always be increasing as you read it from left to right. And it's just like the most important numbers that you might think of when you have a set of data like this. All right. Any questions on the 5-number summary? All right. Let's keep going. You might be wondering why we're even doing all this. Like, why are we finding quartiles, percentiles, all of this stuff? The reason we're going through this is because, well, first of all, quartiles and percentiles are very important in determining these things called outliers. Okay. Now, you've probably heard of this term before, an outlier, and it basically describes something that like doesn't belong in a data set. For example, if you have a group of people who are all like kind of medium height and you have someone really tall, that person who's really tall would be an outlier because they don't seem like they fit with the rest of the group, right? So outliers, basically people or things or items or numbers that are considered either really large or really small, so much that you like, they kind of stand out in the data set. They look too big or too small, okay? Here's an example. We have a temperature in a downtown location measured for 8 consecutive days during the summer. Here we have a bunch of readings here. Which one do you think is an outlier? Yeah, that 8.45 looks a lot different than the rest of the numbers, right? It's way smaller. And it's kind of strange that we have a temperature of 8.45 out of all these days during the summer, which are pretty hot, and just one of them being pretty low. Any ideas on why this might be true, Timothy?
Someone typed in the information incorrectly.
Yeah, right. Someone definitely typed it in. How do you even know that they typed it in wrong?
Because everything else is around 80 something, and so they just missed the second.
True. The other thing I noticed is look at all the decimal points. Everything else has 1 decimal point. The other one has 2 decimal points. So it kind of seems like maybe someone actually placed the decimal point wrong when they typed it in, right? That's what I'm thinking. Like, okay, this should be 84.5, but someone just typed it in wrong. And that's usually how outliers come about in data sets. Like usually someone just typed in the data wrong. There are times when it's just pure coincidence that there was a really cold day out of nowhere. But usually it's data entry error. Usually it's something like that, as opposed to like a coincidence happening and having something really weird happen. Okay. Now, sometimes it's easy to look at a data set and be like, oh, well, 8.45 is obviously an outlier. Sometimes it's a little bit harder. Okay. Sometimes like you're not sure. For example, 79.5 is a little bit lower than the rest of them, but it's kind of weird. I don't know if I would call it an outlier. It could be one, but it might not be, right? It's a little bit lower, but it's kind of like on that line of like, okay, maybe it's an outlier, maybe it's not. It's hard to see here. Okay. Gabriel, do you need the notes from last time? Okay. So in order to determine if something's an outlier without just like looking at it and being like, oh, well, that's an outlier, we actually have a mathematical way to determine if something's an outlier or not. And we have these formulas that will tell us if, well, it's an outlier, if it's not. Before we talk about those formulas, I do want to talk about one thing called the interquartile range. Okay, this is a number that is calculated using the quartiles. And one thing I like about statistics is sometimes the words will tell you exactly how to find the numbers. Okay, and let me explain to you what I mean here. The word range, does anyone remember how to find the range? Michaela, Mackenzie. Every time.
You take the max number and subtract it, and subtract the low number.
Perfect, right? So it's like the largest minus the smallest number, right? So if I'm finding the interquartile range, I guess I'm taking the largest quartile and subtracting the smallest quartile, right? So literally, you don't have to memorize this formula I'm about to give you. It's literally in the name, interquartile range, taking the largest quartile, taking the smallest quartile, and subtracting them together. So I'll give you the formula. It's Q3 minus Q1. This is a formula you should memorize. Okay, but you really don't have to memorize it because it's in the name, right? It's interquartile range. It's the range of the quartiles, Q3 minus Q1. Okay. Now, why do we even need to know about the IQR? Is because it's used in a formula used to detect outliers, okay? So I actually have a method for detecting outliers, okay? The first thing you're gonna do if you're looking for an outlier is, well, you have to find the quartiles, okay? So find Q1, find Q3. The second thing you're gonna do is compute the interquartile range, which is what I have up here, because you're gonna use the IQR in the next formula, okay? The third thing you're going to do is you're going to compute these things called outlier boundaries, okay? There are two outlier boundaries. You're going to have a lower one and an upper one. And these are kind of boundaries that tell you how low an outlier can be and how high an outlier can be, okay? Now, if that doesn't make sense, I think it'll make more sense when we put actual numbers to it. But let me just show you the formula for it. The lower outlier boundary is you're going to take Q1 and you're going to subtract off 1.5 times the IQR. If you're wondering where 1.5 comes from, it's literally a number that mathematicians decided on, okay? So basically, we did a bunch of tests with a bunch of different data sets. We tried to figure out what looked like an outlier and what didn't look like an outlier. And we thought that 1.5 was like the number that makes the most sense and that works the best for us, okay? The upper outlier boundary is Q3 plus 1.5 times the IQR. And these are two formulas that you also should memorize. Okay, now I will tell you that these two formulas aren't like, there's really no like way to memorize it, like using the name or anything. But it's really just multiplying the IQR by 1.5 and either subtracting it or adding it to the quartile. So it is a little bit of work to memorize these two, but I promise you it's not too bad. Okay. Number 4, any data value that is less than the lower outlier boundary is an outlier. If you have a number that's greater than the upper outlier boundary, you also have an outlier. And if that doesn't make sense to you, let's do an actual example and then it'll make a lot more sense when we go ahead and do it. Okay, let's flip to the next page. Below is a list of numbers. I know in the thing it says to create a box and whiskers plot. We'll talk about that like very soon, but we're gonna X out that information and we're just looking for outliers here. So don't worry about the box and whiskers plot yet. We'll get there. Okay. First thing we have to do is order the data from smallest to largest. Remember, whenever we're finding quartiles, median, IQR, anything like that, the numbers have to be in order. I'm going to try to do this in my head, which is kind of a bad idea for me, but we're going to try. Looks like the smallest number is 1. We've got 19 next. I think 20 goes next. 22, no, 21. Ooh, almost messed up there. 22, 24. 26, 30, and 31. I think that looks about right. Thank you. That makes me feel a little bit more confident there. Okay, let me just make sure I actually have this in my notes here. I really don't feel like doing this in my calculator because I know I'm going to make a mistake. Let's see. Oh, I have. All right, in addition to ordering my numbers from smallest to largest, I'm going to number my numbers because I cannot count. I think I've demonstrated that enough in this class, but I think it's easier if I just have the numbers underneath each of these and then I won't make a random mistake during class. Okay, so I have my numbers numbered. The next thing I'm gonna do is find the median. Now, finding the median, of course, you can go and do the multiplication thing. That's totally fine. I just like kind of going through my data set, crossing off pairs, and it looks like my middle number is 22, so I don't really have to do any work there. My median is 22. Remember, the median is also Q2. Okay. Next up, finding the 25th percentile. What's another name for the 25th percentile? Q1, good. And if I want to find my 25th percentile, what two things am I going to multiply together? Perfect. 9 times 0.25. 9 is the number of things. 0.25 is just 25th percentile, right? When I go ahead and do this, I get 2.25. What does 2.25 round to in this class? 3, perfect. Just for this section, by the way, not for the entire class. Is 3 my 25th percentile? No, what is it? 20, good, because the third number is 20, good. Okay, so 20 is my 25th percentile. Next up, we have the 75th percentile, which I'm guessing is Q3. And in order to get the 75th percentile, what two things am I going to multiply together this time? 9 times 0.75. I'm telling you, you are going to get tired of computing these percentiles as this class goes on. They're kind of confusing at first, but as you get like sick of doing this like every single time, it gets a little bit easier. I got 6.75, which rounds up to 7. Is 7 my 75th percentile? No, it is 26, right? So the 7th number is 26. Okay. Next up, we need to find the 5-number summary. So let's go ahead and do that. What is the first number in my 5-number summary? 1, or the lowest number, right? What comes after my first number? 20, because that's Q1. What comes after 20? 22, because that's Q2, or the median. What comes after 22? 26, because that's Q3. And what comes last? 31, because that's the highest number. All right, perfect. Now, I know it seems lame to label each of these numbers, but I promise you, like when you're studying for the test, you'll forget what the numbers actually are in your notes. So that's why I like to label them and have them ready. All right, let's flip over the page. Part F is to find the IQR. Remember, IQR stands for the interquartile range, or the range of the quartiles. I would get that for you, but my feet are off duty. So does anyone remember the formula for the IQR? Q3 minus Q1 is the largest quartile minus the smallest quartile. And going back in what I just found, Q3 was 26 and Q1 was 20. So I'm literally just subtracting these two numbers and my IQR looks like 6. Okay. So why do I find the IQR? Because it's very useful in finding the outliers because, well, they're literally in the formula of the outliers. When I go and find my outliers, the first thing I'm going to do is find my lower outlier boundary. Okay, and I know this one's kind of harder to remember. Does anyone remember the formula for the lower outlier boundary? Jules. Jenna. I know it starts with a J now, but I think it's Julie every time. Perfect. Q1 minus 1.5 times the IQR. That's like the one formula that you need to memorize without actually thinking about it. But once you do it a bunch of times, it'll become like pretty much, it'll become a lot easier. Okay. So Q1 in my notes, it looks like Q1 was 20, right? 1.5 just stays as 1.5. And the IQR we just found was 6. Okay. Now, when I do this, I like to do the multiplication first, write it down, and then subtract. You don't have to do that, but if I don't do it, I'll make a mistake. So 1.5 times 6 is 9. And when I subtract 20 minus 9, I get 11 as my lower outlier boundary. Okay, let's do the upper outlier boundary. Upper outlier boundary. Okay, does anyone remember the formula for the upper outlier boundary? Miranda?
Q3 plus 1.5 times your IQR.
Perfect. And really, as long as you know the lower outlier, lower outlier boundary, it's basically the same thing except Q3 is there instead of Q1, and we're adding instead of subtracting. So literally only 2 differences between these 2 formulas. Q3 is 26. I'm adding 1.5 times the IQR, which is 6. I like to do the multiplication first, write it down, and then add, because if I don't do that, I'm just going to make a mistake. So 26 plus 9 gives me 35. Okay. Now, the way I visualize this is if I had a number line, well, 11, my lower outlier boundary would be like lower than my upper outlier boundary, which is 35. Okay. This is how I imagine finding outliers. Okay. Basically, I have these boundaries that basically contain all my information. If anything is between 11 and 35, then we're good. Okay. But if I do have a number less than 11, it's going to be an outlier. And if I have a number greater than 35, it's going to be an outlier. So basically the outlier boundaries contain all the numbers that aren't outliers. And if there's something less than the lower boundary or greater than the upper boundary, then it's an outlier. So taking a look at our data set here, is there anything that is going to be an outlier? 1, right? Because 1 is less than 11, right? So I do have an outlier. 1 is an outlier, and it is an outlier because it is less than 11. Okay, now we don't have any outliers above 35 because, well, there's nothing above 35. But if there was a number bigger than 35, that would also be an outlier. Okay. Any questions on finding outliers here? All right. Now, we have actually been working our way to creating our very last type of plot that we will learn in this class. And this is called the box and whiskers plot. I'm sure that you probably have seen box and whiskers plots before, probably in like elementary school, but you probably haven't like actually talked about creating one, which is what we're gonna do now. So here's an example of a box and whiskers plot. It looks really weird, but it's basically this box, okay? And it's got these little things that look like whiskers coming out of it, okay? So that basically is a box and whiskers plot. In addition to this plot, we also have these little circles that represent the outliers. So basically the outliers are going to be plotted using circles or stars or smiley faces or whatever you want as little dots on the plot, okay? If we focus in on the box part of the box and whiskers plot, all the vertical lines here represent the quartiles. Okay, so Q1 represents the outside of the box, Q3 is the other outside of the box, and the median actually goes right in the center of the box. Okay, now if you take a look at the whiskers are pretty easy. They represent the lowest and highest value, but it's not just the lowest and highest value. Since we're also plotting the outliers, this left whisker here represents the minimum value, but not just the minimum value that is not an outlier. And the reason for this is because we're already plotting our outliers. So we have to go to the one that isn't an outlier because, well, if it wasn't, then it would just go out to the outlier that I just plotted. Same thing for the max value. This is the max value that is not an outlier. Okay. Any questions on making box plots? All right. Then why don't we just go ahead and create one ourselves? Okay. So we're going to continue the last example and create a box plot of our information here. Now, when I go about making box plots, I feel like I get kind of confused because there's so much stuff going into making the box plots themselves. So I make a little chart on the side just so I can figure out, okay, like what goes where. The first thing I'm going to do is I'm going to write where my outliers are. On the last page, we actually figured out that 1 is an outlier. So I'm just going to say that my outlier is 1. So I have that down. I'm also going to write the important quartiles. Remember, the quartiles go inside the box. So maybe I should write what those are. Okay. Taking a peek at my first page, my first quartile was 20. So I'm going to write that down. My median was 22. And my third quartile was 26. Okay, so I'm just writing my quartiles up on my chart here. The last two important pieces of information that go in a box plot are the lowest and highest numbers that aren't outliers, right? So I'm going to find the lowest number that is not an outlier. Okay, and I know that is not grammatically correct that I wrote on here, but that's okay. Taking a look at our data set. Now, I already know that 1 is an outlier. What is the lowest number that is not an outlier? Yeah, 19, right? Because I can't say it's 1 because 1 is an outlier. The next one up is 19. So that one is going to be 19. I'm also going to find the highest number that's not an outlier. Okay, now we don't actually have any high outliers. So taking a look at my data set, what is the highest number that is not an outlier? 31, right? It literally is the highest number, right? So I don't have to worry about outliers there. 31. Okay. Let's go ahead and make our box plot. All right, when we make a box plot, the box plot goes above a number line. So I'm gonna have to draw a line, okay? if my lowest number is 1, where do you think I should start on my on my gosh, on my number line? We can start at 1. That's totally fine. I'm gonna be lazy though. I'm actually gonna start at 0. I thought someone was gonna say 0, but one would also work. What do you think I should count by? I really don't feel like counting by 1s. I think 5s would work. I don't know. 2s would even be too much. Let's count by 5s. So let's go 5, 10, and there's really no rhyme or reason to what I'm doing. I'm just marking parts on my number line and going up 20, 25. Where should I stop? Yeah, 35 because my highest number is 31. So I guess I'll stop at 35. Okay. When I make my box plot, the first thing I want to do is plot my outliers. Outliers are plotted using circles, stars, or whatever. So I'm just going to put a star about where 1 would be above my number line. Okay, so that's my outlier. The next thing I'm going to do is I'm going to take all my important numbers that I wrote in my chart and make vertical lines to represent where they go. So I'm going to make a vertical line around 19. I'm going to make a vertical line around 20. I'm going to make a vertical line around 22, 26, and 31. Okay. So these vertical lines are going to be like the endpoints or parts of my box in my box and whiskers plot. Whenever I make this, I think it's kind of hard to determine like where the box goes. I think it's easier to draw the whiskers first because I don't know, I think it just makes it look a little bit nicer and it makes me see like where the box should go. Because once I draw my whiskers, I know that everything else that I didn't draw lines around are going to be part of my box. So I'm going to connect the middle ones with lines here. And I promise you that was supposed to look better, but that's okay. Once I've drawn my lines, I've made my box and whiskers plot. All right. Any questions on what I've done here? All right. And if we don't have any questions, I think it's about quiz time.